30 to 40 minutes of fairly difficult theory, I would say. But then after we do the theory, we'll talk about how we would apply what we're doing. And in all honesty, I think this stuff's kind of fun. So the first thing is you have M, which is a set. And it can be a set of anything that you want. Sets don't have a lot of structure necessarily, but this thing, that's a little better. Okay, so M is a set. I don't want to undo all the work you did and turn off the lights, but I might need to turn one off. So M is a set. And D is going to be a special type of function. And what D does is it takes pairs of things from M and it spits out real numbers. And the way to write this formally mathematically is you say that D is a function from the product, the Cartesian product. Main is M cross M, which just means it's going to be two things. The first one is from M and the second one is also from M. And the codomain is R, which is the real numbers. So this is a way of expressing the distance between two things in your space. And there are 4 axioms that you have to have if you're going to be a metric space. 4 axioms you have to satisfy. First is that if you have a point in your M space, distance from a point to itself should be 0. So the distance from X to itself is 0. Second, should it be possible to have a negative distance? So if you have 2 points in the space, the distance between them should either be 0 or it should be positive. What the third thing is it makes sense to say it's 10 miles from me to you, but it's 20 miles from you to me. No, they should be the same distance. I have a pair of points. The distance between them should be the same regardless of whether you put one first and then the other. Of course, the order, you should still get the same distance between them. And the fourth is called the triangle inequality. Triangle inequality basically says you should always be able to take a shortcut. Should never be okay to like go through Y and get from X to Z faster than going from X to Z directly. It just says that if you have 3 points, X, Y, and Z that are in your space M, and the distance from X to Z should be less than or equal to the distance from X to Y plus the distance from Y to Z. So if you think about X being here, Z being here, and Y being here, it should be always the shortest thing should be to go directly from X to Z without taking a shortcut through Y or taking a stopover through Y. 4 axioms of a metric space. And what this is intended to do is to take the notion that we have a distance in the real world and make it so that when we have mathematical things, we can think about there being a distance between mathematical things.